So this next problem asks us to fill in the table and use mid-interval values for the x values of 1, 5, and 7. So if you notice in the previous problem that the spacing was not consistent. So we have at 1 there's no value, at x equals 5 there's no value, so x equals 5 here, and x equals 7, at those points there are no values. So AP sometimes asks you to fill in those values using what we call a mid-interval value. So since the width of the rectangles are going to be 1, we can just take the height as a rectangular area. And since we are going to find the integral of this, we want to find the displacement. So I'm going to just write this in here. So the rectangular area, so the height is going to be -10. So the displacement from 0 to 1 is going to be 10. Now we don't have a left edge for x equals 1, so we're going to leave that blank. At x equals 2, the height's going to be -2. The interval width is 1, so I'm going to have a rectangular area of -2, or displacement of -2. From 3 to 4, the height is 0, so we can have displacement of 0. From 4 to 5, the left edge area is 6. And so the left edge height is 6, and we're going to have a width of 1, so we're going to have a displacement of +6. For 5, we do not have a right edge area, so we're just going to skip that for now. For 6, we have a left edge area of 8, and so the displacement for that interval is going to be +8. And again, for 7, we don't have a left edge for that value of 7. Okay, so when we talk about the mid-interval value, so in AP Calculus, they often want you to find something called a mid-interval value. And a mid-interval value is going to be the estimate for the value at x equals 1. Okay, so at x equals 1, they want to find an estimate for this value. And we use the average y coordinate between the two outside coordinates. So at x equals 0, y equals 10. At x equals 2, y equals -2. So -10 to -2. The average height of that then is going to be at -6. So we're going to use a mid-interval value, which is the average of these two values here. Okay, and that average is going to be -6. And so the rectangular area, or the displacement, since it's an interval width of 1, the displacement will be -6. And we do the same for the mid-interval value at 5. We have a y-coordinate of 6, a y-coordinate of 8. So to find the mid-interval value, we just take the average of those two coordinates, and we get a y-coordinate of 7. And again, since the interval width is 1, our displacement is +7. And then lastly, for 7, we're going to use a mid-interval value between 14 and 8. Okay, so the value here is 14. The average between those two is going to be a mid-interval value of +11. And then we have a width of 11, so that displacement is +11. So now we can use this to find the net change. Okay, and because it is an integral from 0 to 8, we want to have the net displacement. So we need to count the negative parts as negative. So these negative values must be counted as negative. So I'm just going to add this up. So I end up with the integral from 0 to 8 of f of x dx is going to be approximated by -10 -6 -2 +0 +6 +7 +8 +11. Okay, when I sum that all up, I get -18, +19, let's see here, positive -18, -12, -5, +3, +11 is +14 displacement. So we get a displacement that's approximated by about positive 14. And so the difference between A and C really is that one is an area, okay, and the other one is displacement. Okay, so A represents area, and C represents displacement.